into my channel. Here, I will try to guide you all to get the maximum marks in every maths exam question, especially the Malaysian Stpm Maths T paper. Okay, let's jump to it. Today we are going to talk about differentiation of trigonometric function, and this is a part 1 of this series. In part 1, I will basically talk about the trigonometric properties which you need to answer this question. In part 2, I will dig into the things that you need to know for the exam and where marks are given. So, let's look at the formulas. To answer differentiation of trigonometry, you need all these formulas. So the first one will be differentiation of sine x, you will get cos x. The second one is when you differentiate cos x, you will get negative sine x. When you differentiate tangent x, you will get secant squared x. And when you differentiate cosecant, then you will get negative cosecant x cotangent x. When you differentiate secant x, you will get secant x tangent x. When you differentiate cotangent, then you will get negative cosecant squared x. Now, before I continue, please hit the subscribe and the bell button. It's free. If you do that, you will get notified by YouTube whenever I have a new videos up. Let's look at the examples. Now, when you differentiate y equals to sine 5x, what you will get is, following the formula, you will try to create the differentiation of the function, which is 5x, and copy cos fx. So this will give you the answer. Cos fx is the differentiation of sine x. So you will write cos 5x, and you will differentiate 5x, and that will give you 5. And you will write the answer right in front of it. Easy, right? Now, this is 5 as inside the function. What if the 5 transform into the power of the function? What you need to do is just follow the same rule. Differentiate sine fx, you will get cos fx. So the first thing that you're going to write is cos and the function. So for this case is x power of 5. When you differentiate x to the power of 5, you will get 5x to the power of 4. So you will write the answer right in front of the cos. Now, actually, when you look at the books, most of the time, cos fx and the differentiation of the function is put behind. So sometimes when I mark, I notice that if the student put it behind, especially with when you are having the exam stress, you tend to multiply the 5x to the power of 4 with the function given inside the question, and you will get something like this, which is horribly wrong. So I always suggest that after you differentiate, it is best you put it in front. But if you put it behind, then you just need to move it back in front just in case you make this type of mistakes. Okay, now let's look at the third question. The third question, I move the 5 as the power of the sine. So I have sine power of 5x. Notice that the 5 given is actually for your sine x. So what we can do is, we are going to deal this as if we are doing composite function. If you have not seen the video on composite function, I will linking it in the description box below. Please click on it and watch it later. Now, what I'm going to do here is I'm going to treat this as if I'm doing composite function, differentiation of composite function. What will happen here is 5 is going to go in front, copy whatever inside the bracket, and index minus 1. Okay, that's how we do differentiation of composite function. Then I will need to differentiate whatever is inside this bracket, which is sine x. So I'm going to differentiate sine x following this formula, the one for differentiation of sine x. So I will get cos fx, which is, for this case, is only a x. When I differentiate x, I get 1. So my answer remains like this. So I just put them into a proper form. Now, during exam, you do not need to write like d over dx and so on. Okay? Because these two doesn't carry much marks. So you can straight away do the composite function and differentiate your trigonometry. Now, if you notice, I can actually bring out this 5 outside here. And when I'm done with the differentiation, I can bring back my 4 into my sine x. So these are properties of trigo. So you can learn about it in your Sem 1 paper. Now, after you have understand the 3 different types of question on trigonometry that will come with the position of the values, we can now dig into this proper type of differentiation question. For example, if I have y equals to sine 5 to the power of 5 for a certain function, what will happen is this power is actually transforming this whole thing into a composite function. So what will happen is I'm going to deal with the composite method first. So my index go to the front, copy whatever which is given. So this, for this case, is sine 2x plus 1. Then index minus 1, so it's going to be 4. So I'm going to do it directly. So I will write power of 4. Then I will differentiate sine fx. So sine differentiating sine fx will give me cos fx, which will give me cos 2x plus 1. Once I differentiate the cos, I can now deal with the fx. So for this, the function given is 2x plus 1. So when I differentiate 2x plus 1, I'm going to get 2. So I will write it there. To finalize this answer, I would need to rearrange all the numbers and the trigonometries properly. So 5 times 2, I get 10. Recopy the whole thing and this set 2. That is so easy, right? Hopefully you are following me until now. Now, for the 4 examples, I'm using sine. It works the same when you are doing for cos or other trigonometry. Let's look at this one. What if I get cotangent? Now, for this question, it is very clear that composite differentiation of composite function comes in here because they gave you a power outside. Now, what will happen is I'm going to deal with the composite function first. So index is going to come to the front. Then copy the whole thing in the bracket. Then index minus 1. When I'm done with that, I cannot bring this into here. Don't. Okay? Because this is the whole set power of 4. Then I'm going to deal with the brackets. I'm going to differentiate the brackets. So differentiating 1, I got 0. differentiating cotangent 3x squared following the formula is going to transform to negative cosecant squared fx. So I'm going to differentiate it, so I get negative cosecant squared and then my function, this 3x squared. Copy it down. Next step is I'm going to differentiate the function itself, which is 3x squared. When I differentiate 3x squared, I will get 6x. I need to rearrange this. So 5 times 6, I will get the negative 30 because there's a negative 1 here. So negative 30x. Copy the whole set of cosecant squared 3x squared and copy the whole set with the power. Okay, that's all. Easy, right? Let's check out this one. This is given with the power here and a function 7x squared. So what will happen is you are going to deal with the composite first, which means that you are going to settle the 4 to the front. Copy secant 7x squared. Index minus 1, you get 3. Differentiating secant, you will get secant tangent. So you will get secant fx, that's your 7x squared, tangent fx, which is tangent 7x squared. The function now is, the fx now is 7x squared. So I differentiate 7x squared, I will get 14x. Once that is done, I will rearrange all the numbers. So this is what I'm going to get. So that's done. Okay? In this question, again, it comes in the form of composite. So what will happen is, this index is going to go to the front using the formula of composite function. So index to the front, index minus 1, copy the whole function. Okay, once that is done, I'm going to differentiate tangent x or tangent function. Okay, so I'm going to differentiate tangent. I will get secant squared fx. So secant squared, the fx is 1 plus x squared. Next thing is I'm going to differentiate the whole set here. So differentiate 1, I get 0. Differentiate x squared, I got 2x. It's time to rearrange. And it's done. Okay? Okay, let's look at question number 8. In question number 8, given to you is sine to the power of 3 over 2x, which give transform to using this formula. And the second one is cosecant. So it will be transformed into this formula. Okay, now what will happen is I need to deal, because the index is for the sine, so I'm going to deal it as a composite. So index to the front, copy the function sine x, index minus 1, I get 1 over 2. Okay, so sine x power of 1 over 2. Differentiating sine, I will get cos. So I will write cos x because the function here is only x. Now for the one behind, cosecant squared plus x squared plus 1, I will need to deal with the formula. So differentiating cosecant x squared plus 1, I get negative cosecant fx. So I will copy negative cosecant. The fx is x squared plus 1. Then cotangent fx. So I will write cotangent, and the fx is x squared plus 1. Then I'm going to differentiate the function, which is x squared plus 1. So differentiating x squared plus 1, I get 2x. Now I need to rearrange. this square root, I'm not going to bring it inside here because I cannot write square root of sine. So I need to put it outside. So it will transform to this whole sine I has a square root plus my cos x copied. This 2x, I bring it to the front and followed by copying all the other things. Okay, do not worry if you have like cotangent and cosecant in alternate place. No, don't worry about that. Okay, as long as you have what is needed inside the formula. Okay, that's all from me today. In my next lesson, I will talk more about the differentiation of trigonometric function, which is more to the Stpm level question. Okay, please give me a like if you find that this video is useful for you, and please share this with your friend so that everyone can score A. That's all. Thank you. See you again in the next video.